Somebody out there in student land. What do we do to find normal boiling point? We had to find standard pressure, right? So if you draw a graph, if you have a graph, because you're not going to have to draw it on the exam, okay? You're going to have pressure and you're going to have temperature. Let's just say this is our graph. What are you going to have to do? Okay, you're going to find the standard pressure line. So let's just make it KPA this time so we're different. All right, what's standard pressure on KPA? All right, so find the 101 line. And you're going to go and draw a line across. And that intersection will be the normal boiling point. Okay, so anytime you're asked to find a normal anything, you have to draw in a line at what? Standard pressure. Are y'all with me on that, or am I talking to myself? I get y'all don't want to be back. I'm in the same boat y'all are in. I wish we were still home on vacation too. Pained me last night to make my lunch and turn on my alarm clock. Okay? I have a friend who called me just to tell me they didn't go back to next Monday. Okay? I get it. However, your exam is in 8 days. We're not going to finish the curriculum. We need to hit as many highlights as we can to try to help you as best we can. So it would help if you could be a little more interactive this morning than y'all are. Okay? Okay, then y'all are just going to sit there and be duds. Just try to absorb as much as you can. And I'll just talk. Okay? Now, questions on the opening. Fabulous. Now, I told you I would provide 3 opportunities for bonus points on your second quarter grade. Let me make sure I write that down, because some of y'all are going to swear up and down I said semester, and I did not.
Oh, that was the thing that you kept saying over and over again.
Yeah, biology always calls it a blitz. I don't call it a blitz because it's not. All right? It's like blitz. All right? Now, I am sincerely sorry if this affects the basketball team. I know it's going to. I can't fix it for you, Almija, because I know the first date conflicts with the basketball date. I suspect at least 2 do, but I pray it's not all 3. Okay? The dates that I have are Thursday, Tuesday, and Wednesday.
Oh my God.
I had a feeling it probably would be. Monday I have a staff meeting. Otherwise I would have given you Monday. But I can't fix Ms. Curry at her staff meeting. And Thursday I have an appointment. Now, if you come all 3 days, you get 1.5 points.
So if I just come one day, you get half a point.
You get half a point, which rounds up to what? Which rounds up to 1. All right. Now, if you come all 3, it's 1.5. 1.5 rounds to 2. You choose. Those of you who have lower averages, who have spotty information, I'm starting with the oldest material that we've covered. Okay? This is strictly review.
You mean like Thursday, like tomorrow?
Like Thursday as in tomorrow. We only have through next Friday. And then on Monday when you come back, you take the what? Exam.
What's the time? Maybe I missed it. What's the time?
3. I usually start at 3:40, so you have a 10-minute break until 4:30.
Well, I'm not going to get okay, so oh my God, I forgot. Man, you said what?
That's all I can do for you guys.
So, we're at 5:30. I don't think I'm going to
If you have practice with somebody, see if they will be ever so kind and let you come to this for a little bit and then go to theirs. Ask. You never know what they'll tell you.
I'm talking to them. Here's what I'm telling you. If my grade does not
talk to her.
Standards, there will be no diamond. There will be no diamond. My mom will kill me.
Talk to her and see what she says. You might be surprised at what Ms. Rector will say to you.
So exams begin the 14th?
The exams are the 14th through the 18th. That is correct. They are really close.
I have a question.
Mhm.
I don't know if you would know the answer to it, but
Do you want me?
you know how we're allowed to leave at 12:30?
Did you see me on that?
If we have an AP class, how do you know how that would affect that? Like,
You need to ask your AP teacher,
we have to stay.
okay?
And Friday, right?
Because, okay, they'll be able to. Technically, we don't allow y'all to leave. You just leave.
I always
We're
bring
told
a
to
note.
bring the notes that we can leave, and my mom.
I mean, I always, if, for example, if you were my chemistry class for third period, I would be offering these after first and second period exam instead of after school. That's what I typically offer them.
That way we have to stay.
That way you, A, have to stay, and B, it doesn't affect my athletes or you who have Oklahoma. It would allow you to get your half a point by staying during school time. And then after the review session is over, I don't really care where you go. All right? It's not my concern. But because y'all are the first period exam, I don't have any built-in time before you literally take the exam. Okay? That's why we have an issue.
So
You are the first exam.
We are doing it in order.
We are doing it in order, 1st through 4, and then Friday is the makeup day, the 18th, which was supposed to be a teacher work day, is now the makeup day.
I have to be here every.
Okay? And if you're like Sailor and have questions about AP and whether you have to stay for the review sessions and those types of things, ask your AP teacher. Okay? Those days are still working the same way. Attendance only counts through next Friday. Okay? Now, make sure your attendance is in good order. Go into Power School. Check to see if you're on 8. You're allowed up to 8. If you are not below 8 and you have not made up time in either Saturday school or with me to get you below 8, you need to do something. Yes, ma'am.
Does Tyro have Saturday school? I know Central does.
Our Tyro? No.
Oh, good. How much do that too?
No.
So how much time do we have to make up with before?
A day? 90 for 90. I'm not one of those that cuts you an hours a day. It's 90 for 90. All right. So, moving on. I think we've hit the highlights. If you have missing work, see me and we'll set up time or a day to make it work. I know Devontae's got a test where he had the bubonic plague before Christmas. So, if you're in that category and need to make something up, let me know. All right. So, today, we're moving on to kinetics and collision theory. It's thrilling. And we're going to do a graph. Yeah, it's a hot topic. All right, we did all that. We're in good shape there. We're going to do this today, and then we're going to pick up equilibrium tomorrow.
Sorry.
I want to go home.
All right.
Is this gonna go with everything else?
Sort of.
Well, it's gonna go today. It's gonna be on the same page.
Remember what I told you before break?
No.
Well, I told you that it's going to be a little disjointed between now and exam. Simply because I'm trying to hit the highlights of what I think are the most likely topics you will see on the exam. And given I've not seen it in years, I have no way of knowing. I'm just taking a shot in the dark and guessing. Okay?
That is lava.
So, what are the driving forces behind a reaction? Okay? First of all, there are two requirements for a successful collision or reaction. Okay? Now, molecules that are reacting in a beaker, in a reaction, in a test tube, in the crucible dish you used when you did your empirical formula reaction, when you burned the magnesium, whatever the reaction has to be, okay? There are two reactions or two things that are required in order to have a successful reaction, all right? One, the particles must collide with enough energy. Oops, sorry, I read that word. They must collide with enough energy. Now, sometimes we'll use the word sufficient energy. So let me put that out here. Sufficient energy. Now, this energy we're going to refer to today has a name. And we're going to define it later, and we're going to put it on a graph. So I'm going to stick it here so you know where it's at. All right, it's called activation energy. And there's some greasy spot on this board that's driving me crazy. Well, yeah, I can open it with two hands here. It's been 6 months, and the therapist told me on last Wednesday, my last day, that it could be a full year from the break to a year from when I finished therapy before I would notice that most things would work right again. Yeah. I was a little disappointed in that. But there are things that I couldn't do even 3 months ago that I can do now. So, I mean, I am noticing improvements, but, you know, still opening bottles, opening bags with two hands, that's still a struggle. So, it is frustrating. So, you have to collide with enough energy. And number two, come on, erase. The particles must be oriented correctly. Now, when I say oriented correctly, I mean lined up so they connect in a way they can react. And the best way I could describe that for you guys would be thinking about electrical outlets. Have you guys ever gone to plug in an appliance and you've gone to stick in the plug and it won't go in the outlet?
Yeah.
Okay, and what do? You flip it around. Same kind of thing. If molecules hit up against one another and they're not oriented correctly, they just hit and they bounce off. Okay? They have to have the correct orientation. If they're not lined up correctly when they react, they just hit and bounce off. Hit and bounce off. Most collisions do not produce a product. Okay? Most collisions do not produce a product. Okay? So, you have molecules that are flying all over the place. They have energy. They're hitting each other. But if they don't have enough energy or they're not oriented correctly, do they make a product? No. Okay? So what things can we do to increase their chances of success are what we're getting ready to talk about. What things can we do to make this better? Well, that's what we're going to. We can't change their orientation, and we can't physically spin the molecules so they have a better chance of hitting each other. But we can increase their numbers of collisions so they have a better chance of hitting each other. Sort of like playing the lottery. We can't hopefully get the numbers, but we can increase our chances of winning by doing what? Buying more tickets. Okay? Same concept here. All right, has everybody caught up with me? Giving everybody enough time? All right. So, how can we increase the rate of a reaction? Okay? How can we increase the rate of a reaction? All right, which is to increase the number of collisions. Nope, not magic. All right, what's one of the things we can do? Witchcraft is a no. That will not be an answer on the test. If it is, please, God, don't pick it. I'm going to look like an idiot if y'all pick something like that. What can we do to increase the speed of reaction?
Add heat.
Yeah, add heat.
You're right. That's crazy.
Okay, increase the temperature. All right, the molecules move faster. They collide more often.
Is this the first thing?
Yep, it's number one.
How many?
5.
Oh my
I
4 of them I'm hoping y'all can get. One of them you will know. It's not something you would word in a way that would make sense. Although, given none of us want to be here today, I'm not feeling that you're going to get a lot of them.
Wow, thanks. I got one.
Not too high.
And it was
Molly got
more of
Oh, yeah.
Add more of them. Okay, that's correct. Can you give me the name of that? Starts with a C. We learned it before break. Yep. Increase concentration.
Is that supposed to be like MLC, like molecules?
Yes, MOLC is molecules. Okay, if you increase concentration, you increase the number of molecules. So you increase the number of collisions. Sort of like when we change classes. Right now, if I sent you up and down the hallway, odds are very good you can survive without colliding with a soul, right? Nobody in the hallways, other than a couple people maybe going to the bathroom, or they got called to the office, they got called to guidance. I could certainly walk to the office and not hit a soul. I'm fairly large. Now, if I went at 9:55, what are the odds I could make it up and down the main hall and not hit a soul? Pretty remote. Odds are good I'm going to bump into at least somebody who's not paying attention or they just don't care. Okay? So, probably, no, need my job. Too close to retirement to beating up a soul. All right? I want to collect my retirement. All right, so number 3. I would have swore you'd been on a late bus. There were like 3 of them this morning. What bus do you ride?
39. But I didn't.
I was right. I was right when I said 39. Because Denasia was on 274, and didn't I guess 39 first?
Yeah.
You weren't listening, you were talking about my show.
Yeah, you did. Actually,
Because then I said you're wrong.
All right, so number 3. What do you think?
I don't know, buddy.
Yeah, I know. I'm worried about you on that exam. All you need is a decent grade on that exam and you pass. You are so close.
Watch my house.
well, wait, I
Then make up some time.
I just have a question.
Yes.
How much is that towards the
If it's the same policy it's always been, it hasn't changed. If your class average is higher than your exam, then the exam is only 25%. If your exam is higher than your class average, then the exam counts 50%.
The exam is higher than the class.
Yes.
Oh, wow.
So if you do well on the exam,
wait.
then your exam can count 50% of your grade, which is what I'm trying to tell Wally. Because she's been over here moaning about I'm going to flunk, I'm going to flunk, I'm going to flunk. But truthfully, she's hovering, you know, in that closeness area. So this could be the push that puts you in the thank you, Jesus, I passed range. Okay?
Wait, question. I gotta have okay. So if I come for your class, day of the exam, and I don't show what you want, including makeup, are you counting makeup? Like the absence on makeup days?
Attendance only counts for the purposes of 1 through 8 through Friday, like it always does. I have to mark attendance next week, Monday through Friday, for the purposes of a lunch and for fire drill. Have to mark it.
Okay. So
Have to.
if I hit 8 absences, I still pass.
Yes.
Okay.
No one just said it to us
Because
like
that
that,
was
like
right.
bluntly, like they just had 12 times the question. So that's why.
We're not allowed to tell you not to come to school or to come to class.
Well, I'm not.
You're allowed to come.
I'm not allowed to say that out loud, okay? I'm being recorded on YouTube. After Monday's class, you've taken my exam. I have nothing for us to do. Our class is over,
I don't have to do this anymore.
okay?
Yes.
Nothing for us to do. When in the schedule it says first period, if you have someplace else that you need to be, or you have a note to sign out, best wishes, bon voyage, farewell, and see me again some other time, okay? If you have to ride a bus at 3:30, and you are in this building, where do you need to be during the first period time slot? Room 29, first period under Miss Wall's watch during that first period time slot. Okay? It's that simple. I will be in this room during the first period time slot. And you need to be in here if you're on campus.
Well,
Beyond that, if you've got a note or if you without a note, I don't care.
wait, I'm not.
It's that simple. I'm not chasing you down. Number 3, what's the next thing that will affect? Huh?
Nothing.
Say please.
What?
Say please.
Say please.
Yeah, I'm sure we'll do it.
No. Saying please is not going to help us. We talked about the other ones. Well, how about I tell you this? One you learned about in biology class. It would speed up the reaction. Enzymes were a type of catalyst. Okay.
I only know that because of this week.
I
Yeah.
remember that because I don't think I have this.
Okay. Add a catalyst. All right. Its sole purpose is to speed up the reaction. It will force more collisions. What? I didn't hear what you said.
Is this the one you thought we would not get?
No.
Oh.
No, the one that I don't think most people will get is just because it's worded weird. Most people don't think to word that way. All right. Number 4. What else can we do? Think about drying the tennis courts.
Spread it out.
Okay, so what's
Surface
this?
area.
There you go. All right, does everybody have this one?
Is the last time we can do it?
No, the pressure would only affect gases. So we don't list that one because it has no effect on liquids and solids. All right, we there now? All right, so number 4. Increase surface area. All right. Oops, that's not what I wanted. That's not going to fit there. All right, if you spread out the molecules, there's more area for the collisions. Sort of like if you have granulated sugar or cube sugar, okay? If you have a cube of sugar and you have granulated sugar,
Wait, so I've
Okay.
never seen a sugar cube have a
really?
I forgot that was a thing.
I mean,
All right, which dissolves faster? Yeah, the granulated sugar will dissolve faster, okay? The cube sugar will dissolve much slower because it has to attack the outside of the sugar, and it takes a while to get that to happen. Just like solid ice, big cubes of ice will dissolve slower than crushed ice. Crushed ice dissolves faster than cubes, okay? Because you have more surface area. All right, the last one, and the one that I said most people never get, is nature of reactants.
what?
That's why I said it's just worded funny. Now, what that means is some reactants are more reactive than others. So looking at things y'all learned this semester, give me something on the periodic table that you guys know would probably be a fast reactant.
Brancy.
Why?
Because it's in group what?
Okay. So group 1 reacts quickly. Why?
Because it's in group 17.
What's the most reactive one again?
I was about to say Tracy was.
Okay. Both are 1 electron away from 8. Here's the reason. For those of you who forgot, group 1 has 1 electron in the outer shell, so it only needs to lose 1. Group 17 has 7 electrons in the outer shell, so it only needs to gain 1. So they're both the most reactive groups on the periodic table, so they're going to be some of the fastest reacting elements on the periodic table. Now, for those of you who forgot, group 1 is more reactive as you go down. Group 17 is more reactive as you go up. Now, can you think of anybody who would be really slow?
Iron.
Okay, transitions are going to be slower.
Hard and
Yep, nothing wrong with it. Group 14
Oh,
will be slow.
no gases.
All right. Noble gases are pretty much non-reactive. All right.
So do we still include them or no?
I'm going to put them down as largely not reactive. Okay, why don't you want to write? They will react with fluorine But I don't think only reacting with fluorine makes you very reactive.
Was that a definition?
So what?
Is that a definition? Is that a definition?
For nature of reactants, yeah. All right, everybody caught up?
Wait.
All right, how about that?
Wait. Okay.
All right, everybody there now? All right, so one of the ways that the state might ask you to use this information is to draw a potential energy diagram. Okay? Lots of times they take this information and they draw a diagram with it. Okay? So rather than just flat out asking you a question, they might give you a graph to read. So we're going to learn how to read the graphs with the information. Now, potential energy diagrams come in two forms. They can give it to you as an endothermic graph or an exothermic graph. And it doesn't matter which one we learn to draw. You got to learn to read both of them. Okay? They're not very difficult to read at all. All right? Now, the y-axis is usually either going to say energy or it might say potential energy. Depends on the author of the graph as to which one they put there. Okay? Both of them mean the exact same thing. Now, the x-axis is a little more nebulous. Okay? Sometimes they write A plus B yields C. They might even write a real reaction. But something about a reaction is always going to be on the y-axis. I'm sorry, the x-axis. They're sometimes very generic. Sometimes they're very specific. I have no way of knowing how specific this information will be, but it will be something about the reaction. They might even be as generic as, instead of me writing reaction there, they might even be as generic as to say reactants yield products. Okay? They might be that generic. All right? I have no idea. But it'll be something about the reaction. Now, this graph always comes as a line with a hump. Looks like a camel. All right? It's always a hill. Okay? Now, the other graph will be the inverse. It will have the hill flipped. So, from here, we just need to be able to identify the points. Now, because the reactants go to products, the graph starts with the reactants there and the products there. Okay? Is everybody with me on that? Yes? No? Reactants are at the beginning of the graph, products are at the end of the graph. Okay. Now, we said in order for the reaction to occur, there had to be a minimum amount of energy or sufficient energy, right? And I put in number 1 that was going to have a name. It's called activation energy. So we have to be able to find activation energy on the graph. Okay? So, activation energy. They only have 8 days. All right, so we abbreviated E with a little a, and that's probably spelled wrong, but in my tired brain. Get rid of that C. Yeah, get rid of that C. Yeah, I got rid of the C now. I looked it up. Spelling was not my best subject in school. I was a math and science kid. English was not my subject. In college, I saved 2 lit classes for my senior year after I'd been out in student talk. It was horrible. All right, so EA is how we're going to symbolize it. Now, what is activation energy? This is the minimum amount of energy needed to start a reaction. Okay? I always use this as like the amount of energy needed to get out of bed in the morning. Okay? For some of us, this is huge. For some of us, not so bad. Okay? Some people are morning people. Some people are not. Okay? Okay. So you are going to be an endothermic reaction. There's going to be a huge hump for you. All right? For those people who are morning people, and it's not hard to get out of bed, most teenagers are not in that category, then you have a smaller hump. Okay? What? If you were somebody who was low energy? Okay, it's not hard for me to get out of bed. But I cannot say that for my teen years. Now, how are we going to find this?
If I'm an adult. Yeah, unless I'm not going to be an outlier, which honestly, that urge super sounds like
Once you're 18,
yeah, definitely one.
If you become one, please don't invite me to your show.
why would she?
I've had a student do that.
Oh, wait, what? What's happening?
Did what?
Yes. Did you go?
No.
Oh.
I said thank you, but no.
Like there's
Teacher support.
She told me she was very good too.
I guess you'll never know.
I think I heard her feelings.
How long ago was this?
Not that long ago either, about 5-6 years ago. I'm not telling you all that. No.
You know what? I don't know.
She still lives in the community, and some of you would know her. No.
Is she up on the wall?
Now,
Yeah.
I don't think I have a picture of her up there.
Make me sick.
Now, you go from the reactants to the top of the curve to find activation energy. I'm just telling you, if you're going that route, just don't invite your teachers to your show. It's the height of tackiness.
I don't think I'd be comfortable with that, honestly.
We're not.
I
Now, you will also have to find reverse activation energy. Okay? Reverse activation energy has an accent mark. So, where do you think we would start to find the reverse activation energy? Yes, the products.
Really?
Yep. So that's from the products to the top of the curve.
It's cold now.
Okay?
You have a jacket?
I don't need it.
All right. Once you've all got it, we're going to label it on our graph.
Why? Okay.
Okay? Because I want you to know how to find it on the exam.
Are we gonna have?
This, if I had to guess, this would be one of the graphs that I would say you will see. If I
Have
had
you
to
had
make
to
a guess.
guess? Have you ever been paid to guess?
No.
Okay, then.
I'm just guessing blindly because I don't ever get to see the exam.
Why?
Is the accent on the A supposed to be?
Yeah.
Yes.
Oh,
The reverses will have the accent marks.
Okay.
Because we're going to do two of them. And we'll do the next. All right. So if we go back to our graph. So activation energy has to go from where to where? All right. So the reactants are here. To the top of the curve is the activation energy. And you're going to do this with real numbers in a few minutes on graphs. Okay? So from the reactants to the top of the curve is the activation energy. Now, where would we go to do the reverse activation energy? Okay, so the products are down here. So from the products to the top of the curve.
Can it not be the
I was
same
about to
one?
say, wouldn't it be the same point?
Is the reverse activation energy. You're going to the same top of the curve. So the products are not in the same place.
I'm gonna ask again.
Now, the last thing we have to figure out on the graph is enthalpy.
Wait, so you like,
So you like,
okay, so you're coming up with the product, you see where like the lines for reaction, you wouldn't like have those lines like on top of each other?
they could be on top of each other. Yes, I'm just trying not to mess up my drawing. But yes, they could be exactly on top of each other. I'm just trying to label it so you can see it.
Wait, what's the, okay.
What's what? They're asking if the blue and red line could be on top of each other. And I said yes. I'm just trying to label it so you can read it. Say what?
You make a purple one. Because I'm glad I didn't lie.
We're not teaching art class in complementary colors.
I mean, I studied art, so I'm better at art than I am at art. So that's a lot.
All right. Enthalpy is heat content. Yes. Now, enthalpy is a fancy science word for heat content. We have to know if heat is absorbed or if heat is released on that graph. Okay? Now, we've used the words heat absorbed and heat released this semester. Anybody remember the words? Yes. Okay, so endothermic and exothermic. All right, so what did it mean when we said endothermic?
Heat is absorbed.
Heat is absorbed. What did it mean when we said exothermic?
Heat is released.
Heat is released. Now, enthalpy, which is heat content, has a symbol. We call it delta H. Okay? Symbolized by delta H. Now, remember back when we calculated Q and Q was always a positive number? And I told you way later in the semester we talk about when we could have positive and negatives. Now is that time. Because now endothermic means that delta H is positive. Exothermic means delta H is negative. Now, how are we going to figure out if it's endo or exothermic? Yes, and I'm going to label it here in just a second, but I want to go back to the graph and ask, because some of you can figure it out looking at the graph. I'm going to. She hit her funny bone. Oh, she hit her funny bone on the lab counter. All right, are we ready?
No.
Wasn't funny, was it?
It really hurt.
That was cute.
You shouldn't hit your head on
Wow, I think.
I'd rather have
it many times. It was worse than when they were taller. They'd lay their head back and crack their heads. Because they're about 4 inches shorter than they used to be.
Sailor, are you okay?
I had a headache before they had a headache.
Now they largely hit their heads on the electric outlets.
Wow, I've done that. Oh,
Like where Sailor's head is and where her desk is lined up, it's really easy to lean your head back and hit it. All right, we there now? All right, so if we look at the graph, how can we decide if it's endo or exothermic? Looking just at the graph. All right, we're looking at the lines. And what are we looking at with where the reactants and the products are?
The one with the little.
Wait, say it started.
We're trying to figure out if the graph is endo or exothermic based on where the reactants and the products are. How do you know if it's exo or
Because it goes down. Energy.
and energy is what? Okay. Now, look at where the products are. The products are what? They're down, they're lower. Okay? The products are lower in energy, which means energy is released. Does that make sense? Reactants are here, products are here. Products are lower in energy, which means energy is released. That tells us it's exothermic.
Okay.
And here, I'm going to write it over here. I'll come back. So on your little rules, it's exothermic if the products are lower than reactants. So what am I going to write for endothermic? You can. Okay. Endothermic products are higher than reactants. Okay. So there are the two rules. That's how you figure it out. Diamond, hush. You write slow, so write before you tell me to wait again. Write that, and then I'm going back.
I don't. That's a lot of work, and I don't have enough room for that.
Okay.
You didn't tell me to leave room. So.
I did actually say that a while ago.
You did?
I swear you did.
I must have just did it in my head then.
Yeah.
If I see
Yeah.
I just.
So actually,
If I write it on the graph,
oh, got you.
All right. Does everybody have who wants it then?
Yeah, I just need to go back so I can write like.
Wait, don't go back. I'm not ready yet.
Mm-hmm.
She just agreed with you calling yourself slow.
All right. Are we good now? All right. There for Diamond.
Thank you.
Let me write this.
So while Diamond's writing, if this is exothermic, is delta H going to be positive or negative?
Negative.
All right, so delta H is going to be negative. Now, we're going to have to label delta H on the graph. So, how are we going to find delta H? Any guesses as to where delta H is?
The top of the curve.
Top of the curve is just EA.
Man, you won that hump for it.
Find delta H. What do we do?
Oh, yay.
Wait, so you have to split? Oh, I thought it was just like somewhere.
Remember, we're going to do this with numbers in a few minutes. Okay? So you're going to have to find and use the numbers. You go from the reactants to the products. So whatever the reactant number is to whatever the product number is, you just subtract those. And you know that it's going to have what sign?
Wait, say that again.
Negative.
I did not take that in at all.
You're going to use numbers in a few minutes because we're going to do this with a graph that has numbers on it. Okay? So you're going to take whatever the reactant number is and subtract the product number. It doesn't even matter which way you subtract because you know the number is going to be what? Negative.
Oh, I thought it was more complicated.
Now, what if you want to do the reverse?
I don't want to do
You're going to have to do the reverse.
Add.
It's gonna be products or reactants?
Same thing. You can say products minus reactants if you want.
Wait,
But it's the same thing. The only difference is it'll be what? It will be positive. They're opposites of each other.
so when you say reactants to products, you mean reactants minus product?
Yeah.
Okay, so I'm just gonna write the minus.
You're just subtracting them. But remember, you'll know the sign based on which way the hump is with the lines. Because you'll be able to tell that. If the products are lower, it's negative. If the products are higher, it's what? Positive. Does everybody have what they need? E?
I think so.
Okay. Okay. So, if you have what kind of graph is it?
Endo,
How do you know?
because the products are higher. Yeah. Do you need to draw that?
Up to you. They're your notes.
I-
Okay? Products are higher. Everybody okay with that? These are the reactants. Those are the products. And the products are higher. That's how you know it's an endothermic graph.
Okay.
Not next Monday. Following Monday. You have 7 days after today. And y'all test.
Okay, so wait, is this the one where you would do products minus reactants?
Doesn't matter. You're just going to subtract the two numbers. And you know the delta H will be positive.
Oh,
Okay? So you know here, delta H will be what number?
positive.
It's positive because you said it's endo.
This is so much.
So don't scratch the floor. Okay.
And just like, this helps me remember the exercise.
I don't think this is hard.
I mean, I'm just saying, I've never remembered
How many years?
I've done it for a long time.
It should not be hard.
I would be concerned if it was hard.
No, but out of some of the things we've done, I don't think this is hard. Put it this way.
I'm just.
Friday will be much harder than what this is.
That's what's that.
So what's tomorrow?
I'm not coming.
Friday we're shifting.
I mean, I know this wrong Thursday, but
I
Tomorrow we're calculating equilibrium constants. Tomorrow should be pretty easy.
Oh, good.
I love the straight.
Tomorrow should be easy. Friday, you don't think I left my senses a little.
Heteros.
You know.
Holy moly.
Alright. Does everybody have a graph? I think I have these saved. Let me see.
I looked at it and was
It says
like,
heteros.
cool, thanks. Okay, so are you doing this right now? Or are you showing us something first?
We're going to do one together first. Because some of y'all will be lost if I let you loose on it.
I'm gonna be lost. What's the difference?
Do twice double. Then what?
What are you? What are you trying to do?
Let's see if this is it.
Oh, yeah. Self-denial.
You know, there is some crazy person in this world who looked at this, or who would look at this and say,
Yeah.
Asexual.
Alright, that first one says. Alright, there's the first one. Alright, so we want to find four things. We want to find EA reverse, delta H, and delta H reverse. Those are the things you're going to find. All right, where did we say activation energy starts at? If you need your notes, use your notes. Where does it say activation energy starts?
Wait, no.
Reactants, and it goes to where?
Top of the
product.
oh.
Wait, no.
I said you could use your notes. It goes from the reactants
To the top of the curve.
to the top of the curve.
Okay.
I mean.
All right, that's activation energy.
Okay.
All right, so it starts at what number?
What number is that?
Negative 20.
-20, and it goes to where? All right, now this always causes issues. This is a number line. We're going from -20 all the way up to 80. So on a number line, how many numbers are we going from? -20 to 0 is how many? And 0 to 80 is how many? So how many numbers did we go?
I was totally about to get that wrong.
Y'all are a pest. Have I ever told y'all that?
No, because you love us.
Yeah, I was gonna do that all along.
You're still a pest.
You love us.
You do know that's law.
Did you just call her a pest?
Bring my keys back, put the lock on top. All right, so to do reverse activation energy, you go from where to where?
The product to the top of the thing.
So the products are here. All right, now we're only using whole numbers here. I go all the way across and it's at 60
Wait,
to the top of the curve.
wait.
What? We are not going to try to figure out if it's like 57 or 58.
I wasn't gonna.
Okay. Okay.
100, is that KJ over mole?
Yes, that's what that unit right there is. KJ over moles.
Is that the?
What is the K? Is the
You don't have to lock it back. Just put the lock on top and bring me my keys. Because you got to put it back at the end of class. So, and I don't know if you're starting the flood of people who need one.
Oh, it's just Katie. She won.
Who? Oh, what are you, her feet? I thought her foot was healed. I thought her foot was healed.
She's scared.
Oh, okay.
Thank you.
You're welcome. So we started at products, which was what? Started at what number? 60, and it went up to what? So what's the difference? So we write 20. KJ over M. Now, will activation energy ever be negative? No, it will always be positive. Okay? The only things that can be negative are what?
Delta H.
Delta H. And only if it's what? Endo or exo?
Exo.
Exo. Exo is negative. All right, so when you look at this graph, is this graph exothermic or endothermic? All right. Change colors here. It's endothermic. So that tells us delta H is what? Positive. All right. Exothermic will be delta H reverse, which means it's going to be negative. Okay? Everybody with me on that?
Wait. You have to find both.
Yeah, you got to find both. Huh?
And that's what the delta H and delta.
Yes. So that's why I'm telling you, you know the signs.
Okay.
As soon as you can say the products are higher. Okay? Everybody good with what Diamond came up with? The products are higher. That's how she knew it's endo. Okay? That tells us endo means delta H is positive. That means the reverse has to be what?
Negative.
Has to be negative. They're opposites of each other every time. That never changes. So delta H is positive. Reverse is negative. The number will be the same because it's always products to reactants. So what are the products at? Okay? Where are the reactants at? So how far on a number line did we go? 20. So 20 and 60 is what? Positive 80, negative 80. What's the unit that goes on? Yep. kJ over mole. Kilojoules over moles. Is the energy unit joules? Kilojoules over moles. With that one, I want you to do the next two.
What?
Oh,
Wait.
God.
Okay.
Yes. How much?
No.
You stress me out.
I stress a lot of people out.
You don't care about us.
I do. I want you to do well on the exam.
You don't pass. Sure.
I want Lolly to pass.
I think Molly can pass.
I would really like Luis to be my only failure. He can pass. Everybody else in here still has something.
Everybody's so
He ain't even gonna show up.
I would say you only make the highest.
Yeah, that's okay.
I like
the one thing we did.
Yeah,
I
I'm sorry.
remember Miss Michael last and they all cheated.
Yes.
Everybody's
got a
All right, next two graphs. Find me the answers. I'll leave that one there so you have a sample. Go out, Mash. Come on. Yes, you were. Mm-hmm. Yeah.
When you're finding delta, you only go from
From the
the reactor to the product.
correct. Question, anybody? Yes. Mm-hmm. And y'all bring this up, I'll keep these two things. Each are backwards. So that's it, about 10 now. That was the problem we had, you couldn't tell it was a 10. But you can see Grace.
That's fine.
Usually, yeah, first one.
I mean,
That's what.
yes. Yes, sir.
All right, so reverse, you're starting low. So you're going here, all the way here. So you're going here, 0, 2.
It says it right there.
You're going from -40 to 0 to power.
Yeah, but that's,
40, and then 0 to
even
20.
though it's always.
60.
That's
You
the
can
bad
find
one.
this one.
For which
All
one?
right, and the only thing you got wrong with others is this indirect side. So, it's side true.
Because that one is.
But she didn't say that.
So make that negative.
Okay.
All right, can we look at what you came up with?
No.
Why not? Looks like I got about half a class that's with me and half a class is not.
We got 15 minutes.
All right. Now, what I don't get to today, like entropy, it just drops off the schedule. We just don't get to it.
Oh. Okay.
Okay? Tomorrow we go on to chemical equilibrium. Okay? We're on a tight schedule from now to next week. So, this is the reactants. These are the products. EA starts at the reactants and it goes to the top of the curve. So, we start at 0 and we go to 20. So, EA is what? It's 20. We went from 0 to 20. EA reverse starts at where? The products. The products are at where? -40. So we're going from 40 to 0 and then to 20 because we're going from here all the way to up there. So how far did we travel on the number line? If we started -40 to 0, that's what? That's 40. And from 0 to 20 is how much? So that's 60. And they're all kilojoules per mole. All right, delta H. We go from where to where? To do delta H. We go from the products, which is what? 40, to the reactants, which is? So they're both 40s. Okay, now, is this reaction endo or exothermic? Are the products higher or lower?
Lower.
Products are lower, so that means it is exo. Exo means what? Positive or negative? So we're going to put a negative there. That means delta H is positive on the reverse.
I don't understand why though. So can you?
It's a rule. You just have to memorize it. There is no why to it. It's just the rule. Endothermic is a sign positive. Exothermic is a sign negative.
That doesn't help me.
We'll be thankful I'm scrapping Gibbs.
How did you find out? I know how you found
It's just
Delta H.
EA.
I don't
opposite.
No, it's just a rule.
I don't know how.
They're arguing in the background and I cannot hear you.
I know how you found EA with the dash. I just found it.
How'd I find the what?
EA, like,
Reverse?
no.
EA forward is from the reactants to the top of the curve.
Okay.
So the reactants are here. Are you okay with the reactants are there?
Yep.
So they're at 0. So from 0 to the top of the curve is here. The top of the curve is at 20. So from 0 to 20 is 20. Okay?
Like this.
I'm sorry. All right.
And then the rest just goes from the products to the reactants.
Uh-huh. So if we do this one. All right. Where are the reactants at? They're at 0. Right? Here are the reactants at 0. Are we okay with that? So where's the top of the curve at, Almija? Okay, so EA would be what? We start at 0 and we go to 70. What's EA? 70. Okay, so if we do the EA reverse, all right, where are the products at? Okay, so we're at 10 and we got to go to the top of the curve. So what's the EA reverse?
Wait.
60. Because you do 10 minus 70. 70 minus 10 is 60. Okay, delta H and delta H reverse. All right, so what are the products at? 10. What are the reactants at? So 10 minus 0 is 10. And then when you look at the graph, is it endo or exothermic? Are the products higher or lower?
Endo.
They're higher. They're endo. So since they're endo, that means positive. So delta H is positive, and that's negative. Everybody there? All right. The back to our homework for tonight. All right. Let's talk entropy.
We don't have.
Wait, there's more notes for you here.
Let me think about it for a minute. Yes, I'm serious.
It's only been 5 minutes.
Yeah.
Entropy means disorder. Okay? If you substitute the word disorder for entropy, you should be able to answer any question they would ask you about entropy. All right? It has the symbol delta S. Now, they're going to either ask you about a chemical equation with entropy, or they're going to ask you about states. I don't know which. They may not ask anything. I'm hoping for nothing, given I'm going to teach it in 10 minutes or less. Now, there are essentially 3 states of matter, and I'm going to throw in a 4th because I'm going to talk about aqueous. So you guys know solids, liquids, and gas. You know fixed positions. You know mostly tightly packed, but able to move around. And you know very loose, freely moving. Who out of these would have the most disorder or the most entropy?
Yes.
That's right. Okay. who would have the least entropy?
Solid.
That's right. Now, I drew these pictures mainly because we want to put aqueous somewhere in this continuum. Okay? What did aqueous mean again? Does anybody remember?
It's like
The
an
cells
acid.
has water.
Acids are all aqueous. Okay? It means dissolved in something, not just a liquid. I need a different word. What'd you say?
Water.
Dissolved in water. Okay? So, aqueous means dissolved in water. So, if solids have the least entropy and gases have the most entropy, where are they going to fit in the continuum? Are they going to be between the solid and the liquid, or are they going to be between the liquid and the gas?
Solid.
That's where most people put them.
That's wrong.
They're between the liquid and the gas.
How do you dissolve?
Okay.
Aqueous goes there. Now, why? Because water is the same as a liquid, right?
Yes.
And what did we do to the liquid? We put something in it and dissolved it, right?
Sure.
So did we make the liquid more disordered or less disordered by putting something in it and dissolving it? We made it more disordered, which is why it fits between the liquid and the gas, okay? So if you put, let's say, Kool-Aid, go ahead, put it back for her. You're doing it for Katie now. She's so afraid she won't even come in and put a computer up. That is so sad. All right? Next time, y'all need to tell her she has to come do it herself, or she can't have one. Now, if you think about it, that goes for any of y'all who take course next semester. If you need a computer, you need to come get it yourself.
I mean, I won't.
Okay, if for no other reason than say hello. Now, yeah, I'm just mean that way. So, if you think about it and you make Kool-Aid, what do y'all do to make Kool-Aid? Put the powder in. So you have water, you dissolve powder and sugar, right? That increases the disorder inside of the water, okay? So you have greater entropy. So, if we were to make a greater than or less than, okay, this would be the least entropy, and this would be the most. Now, is everybody with me on that? Because we're going to translate this into an equation with our 5 minutes. Yes, I'm looking at the time. And I probably have less than 5 minutes because I'm sure the school time is not real cell phone time. So we might do this with like 2 equations and be done. I'm just trying to give you a leg up on the exam.
Okay, well, question.
All right, everybody got it?
No, wait, question.
Yes,
So can you post the rest, like the old video on the website? 'Cause
I can.
watched one, 'cause I want to pass it.
I can.
This goes for you.
I can. All right, everybody got it? All right, 2 quick equations. So suppose you have Ca, CO3 is a solid, and it becomes CaO plus CO2, which is a solid, and that's a gas. And you have H2O. Let's do it this way. Let's say H2 as a gas plus oxygen as a gas, and you become H2O as a liquid. All right, and we want to know what happens to the entropy. Does the entropy increase or decrease?
Increase.
All right.
Wait for
What do you, for either of them? So we're going to start with the top. So when you look at it, what do you think you look at?
The SSG.
Usually the states, just like we just talked about. So you have 3 of them. But it really doesn't matter that there are 3 of them. What does this side start at? And what does it essentially become? Becomes a gas. So what happens to the entropy if you start as a solid and you become a gas? It increases.
Isn't that it?
That's it. That's all you got to do. All right. What can you tell me about the bottom one? It's a gas. Changes to a liquid. So entropy decreases. Now, that is really a quick discussion of that
So we're done.
for right now. Now, you have 2 graphs to do for homework. You have a multiple choice and an entropy thing to do for homework.
Great.
I'm coming. Hold on. I need somebody to help me pass out one. If somebody would be ever so kind.
With the stuff you just gave us, you expect someone to be so kind.
Okay, don't be kind. I don't care. Y'all just take me longer to hand it out. Y'all be stuck here with around me go. Now, on the one that Almajin is giving you, you are only doing the side that says entropy. The side that says give. Did you hear me talk about give free energy today?
No.
Do not do that side. We're not even going to do it. It's been cut thanks to the weather. Okay, I photocopied this stuff before it snowed. So we are only doing the side that says entropy. The paper I'm giving you is 13 multiple choice questions. And you got 2 graphs. Got one. Yes, you should have.
What is happening?
If y'all got some more room
Thank
back up here.
If you got extra, don't have enough, let me know.
I have extra.
You didn't hear the days for the blitz/review. 3:40 to 4:30 tomorrow is Thursday, next Tuesday, and next Wednesday. You get half a point on this quarter grade. If you do all 3, it's 1.5, which is 2 points added to your quarter grade. Okay?
So you said, if I'm real late, anytime this week, you know,
If you're late anytime this week, detention is next Monday. If you were late last week, Merry Christmas according to Mr. Shaw. No detention. It's a shame. You wouldn't have to make it up. Should have been late last week. If you got a calculator, put it away.
I told my mom, no, look,